Hey everyone, my name is Sarah, and today I'm going to be talking a little bit about dynos. Not that kind of dyno. A chassis dynamometer, or dyno for short, is a tool that we can use to test the output capabilities of a vehicle without having to take the engine out. So in this presentation I'm going to go over a few things. The first is a brief vehicle safety inspection that you're going to want to go through before you run the vehicle on a dyno. I'm also going to go over how to set up a vehicle for a dyno test and running the test itself. So first off, what could possibly go wrong while running a test on the dyno? Well, there's a few things. You could blow a tire, which will obviously damage the vehicle quite a bit, as well as possibly do damage to the dyno itself. You could blow the engine, which is obviously something we would like to avoid at all costs. And then there's also the possibility of the vehicle jumping off of the dyno, which obviously will cause quite a bit of damage and could possibly injure or kill anybody that happens to be standing in the wrong place. So there's a number of things we can do to mitigate these risks. One of the main things you should look at before doing a dyno test is the tire condition of the vehicle. Obviously you want the rubber to be in good condition. You want the wear patterns to be relatively even and nothing extreme. You don't want belts showing or anything like that. No nails sticking out, stuff like that. Also, proper inflation is super important. This information can be found on a sticker generally located inside the driver's side door jamb. As you can see on my vehicle, the specs call for a 32 psi when the tires are cold all the way around. So you'd want to go through, take a pressure gauge to each tire, especially the drive wheels. The non-drive wheels, it's not as important, but since you're doing it anyway, you may as well do all four. Once you ensure that all the tires are properly inflated, you're good to go there. And lastly, you want to take a torque wrench to the lug nuts and make sure they're torqued to spec. Because the last thing you want is a lug nut to go flying in the middle of a test. Another thing you're going to want to take a look at is fluids. You want to make sure that the vehicle has the proper type and amount of fluids in it, particularly oil, coolant, and transmission fluid. You want all the hydraulics to be working as they should, and you also want the vehicle to be able to maintain a normal operating temperature. You don't want things to get too hot. You also want to check and make sure that fluid condition is good, so no milky coolant or milkshake oil, anything like that. And if the oil hasn't been changed in a reasonable amount of time, you want to look out for things like that. Now, in order to set up the vehicle on the dyno, you're going to want to do a few things. With the bar in the upwards position, you're going to want to move the drive wheels of the vehicle onto the lift bar that's located in between the rollers. Once the vehicle is there, you're going to want to lower the bar so that the drive wheels kind of settle in between those rollers. At this point, you're going to want to turn off traction control if it's equipped, and then carefully drive the vehicle so that the car centers itself on the rollers. At this point, shut the car down and put it in neutral. Then you're going to want to chock the 9 non-driving wheels, as in this picture you can see the chock on the front. Set up tie downs for the rear of the vehicle. You're going to want these diagonal. And it depends on the vehicle where you do this. Some vehicles have tow hooks that you can use. Others you're going to have to wrap the ties around the axle. But whatever you use, you want to make sure that it's something that is relatively stable and is not going to be anywhere near any moving parts and isn't going to be pinching things like brake lines or fuel lines, etc. And for these ties, you want them to be snug at this point, but not tight just yet. Then you're going to tie down the front of the vehicle, this time tightly. And once that is secure, then you go back to the rear tie downs and tighten them up. You're also going to want to make sure that you place a fan in front of the vehicle to blow air over the radiator as the test is taking place. This is to emulate the air that would be rushing over your car as you drive down the road. This helps pull heat away from the radiator and allows the vehicle to maintain a reasonable operating temperature. And you're also, of course, going to want to set up an exhaust hose in order to avoid filling the workspace up with exhaust, which is toxic. You don't want to do that. As far as running the test goes, on the Dyno software, there's usually a place to input the vehicle information. This will give you this other information that you will need to proceed with the test, such as horsepower at 50 miles per hour, weight, etc. At this point, you would select the test to run. In this case, we're going to pick power curve, set the start and stop RPM that you want to use, insert the vehicle weight. Depending on the program, all of this information might already be in there for you. Otherwise, you'll have to enter it yourself. Also input the horsepower at 50 miles per hour. And then once that's all set up, you get in the vehicle, you drive it in a direct drive gear. Usually this would be third gear. Whatever gear it is in your particular vehicle, that's a 1-to-1 ratio, and then you accelerate until you hit the stop RPM that you set earlier, at which point the program should be able to do all the calculations for you. And just as an example, the following is a video of a Dodge Challenger that is being put through one of these tests. And lastly, I'm going to talk a little bit about IM240. This was a load mode emissions test that was introduced in 1995. It was required in areas with poor air quality and was introduced as an attempt to reduce carbon monoxide, nitrous oxides, and hydrocarbons. Required an inertia dyno to run, which was a problem for a lot of shops because these dynos cost $150,000 a piece at least. And the evidence was kind of sketchy as far as whether or not this additional measure in emissions testing for inspections was actually making a difference in air quality. As a result of a lot of customer backlash and shop backlash, requirements were loosened in 2000 to make testing easier on shops. It allowed them to use modified versions of the test that, could use cheaper dynos or more accessible dynos. Essentially, the EPA was just looking for a way to test emissions in driving conditions because, unfortunately, an idle-only test doesn't always catch all emissions problems. But now, the computers and onboard modules on our vehicles are far more capable now than they used to be of detecting emissions problems that could result in lowered air quality. So doing a drive cycle emissions test is becoming less and less necessary in order to achieve the same results that the EPA was looking for. So just to conclude, today we talked a little bit about things you should check over on a vehicle before running it on a dyno in order to maintain a safe environment. Also talked about how to set the vehicle up on a dyno in order to run a test, a little bit about running a power test itself, and then lastly I talked about the IM240 test, what it was, why we did it. Thank you for watching my presentation. If you have any questions, please feel free to leave a comment in the section below, and I'll get back to you as soon as I can. Thanks.